Hello, fourth grade teachers. Today we are going to look at Unit 4B, Investigating Fractions and Decimals. The purpose of this video is to provide an overview of the standards, suggested pacing, and sample some instructional strategies. In this portion of the video, we are going to review the AKS and Indicators of Achievement, or IOAs, for Unit 4B. The AKS is the overarching knowledge and skills that students are expected to master. The IOAs are the learning objectives that allow students to demonstrate mastery of the AKS. The AKS and IOAs may not be taught in their entirety the first time they appear on the instructional calendar. Some AKS and IOAs will appear multiple times throughout the year. In Chapter 2 of the video, we will look to see how the AKS and IOAs in this unit are paced in detail. Unit 4B has one AKS. Under the AKS, you will find the Indicators of Achievement, or IOAs. In Unit 4B, you will teach all of the IOAs for AKS 4MA-C5. When learning this standard, students explore the relationship between fractions and decimals to solve real-life mathematical problems. When learning this AKS, students find equivalent fractions with denominators of 10 and 100. Student experiences focus on working with these ideas conceptually, modeling with base 10 blocks, decimal grids, number lines, and other place value representations to explore the relationship between fractions with denominators of 10 and 100. When exploring place value relationships of decimal fractions, the most basic idea for students to understand is the 10-to-1 multiplicative relationship between the values of any two adjacent positions in a number. In terms of a base 10 model, the pieces represented by each of the values increases as you move to the left. Each place value to the left is 10 times more than the place to its right. Each positional value to the right is 10 times less than the place to its immediate left. The work completed by students in fourth grade is foundational for performing operations with decimal numbers in fifth and sixth grades, as well as understanding the 10-to-1 relationship among positional values extends indefinitely in two directions. Flexible thinking about place values is important when exploring decimals. Students make 1/10 from 10 units, transforming smaller units to a larger unit or a larger unit to smaller units. For example, students think about 6/10 as 60 hundredths. Students understand the decimal point marks the location of the ones place, and adding zeros to the right of a decimal number will not change the number. Notice the extension IOA 5D. Extension IOAs support the differentiated needs for your students. As you can see, the word extension is bolded in parentheses to notify that these are extensions and are specific to Gwinnett County. Please note, you will not find resources from the state of Georgia for these IOAs. As a reminder, the state coding is listed with each GCPS IOA, so you can find resources on the Georgia DOE website. In this unit, IOA 5A and 5B are clustered. For IOA 5A, students demonstrate and explain the concept of equivalent fractions with denominators of 10 and 100, using concrete materials and visual models. Students add two fractions with denominators of 10 and 100 while solving authentic mathematical problems. Students express fractions such as 3/10 as 30 hundredths and add fractions such as 3/10 plus 4/10 equaling 34 hundredths. Students are given multiple opportunities to use visual models to develop part-whole reasoning when building an understanding of equivalent fractions, and students use mixed numbers and fractions greater than 1. For IOA 5B, the conceptual understanding of decimals, how they relate to fractions, and decimal notation are introduced for the first time in fourth grade. Students will engage in multiple opportunities to explore and reason that a number can be represented as both a fraction and a decimal using area, length, and set models. Students make connections between fractions with denominators of 10 and 100 and use decimal numbers on a place value chart. By reading fraction names, students say 32 hundredths as 32 hundredths and rewrite this as 0.32 or represent it in a place value model. It is essential that students conceptually understand that decimals, like fractions, can be used to show a value that is part of a whole. Even though these are different ways of writing the numbers, 32 hundredths written as a fraction is the same as 32 or 0.32 written as a decimal. The values are equal. A significant goal of instruction in decimal and fraction numeration is to help students see that both systems represent the same concepts. For IOA 5C, students build and use visual models to compare decimals, including area models, decimal grids, number lines, and meter sticks. Multiple opportunities are provided to students in order for them to use models and develop part-whole reasoning when comparing decimal numbers. Through these experiences and their work with fraction models, students build the understanding, recognition, and reason that comparisons between decimal numbers or fractions are only valid when the whole is the exact same size for both cases. Students solve problems with decimal quantities presented within authentic situations. They determine and explain through investigation the relationship between decimal numbers using a variety of tools such as concrete materials, drawings, number lines, and strategies. For Extension IOA 5D, the purpose of this Extension IOA is for students to use their creativity, critical thinking, problem solving, and reasoning skills to determine their own way to apply the understanding of this AKS through various platforms to show the application of skills and concepts in the real world.
In Chapter 2, we will be discussing our Unit 4B pacing. Our pacing guides are closely aligned with the state pacing to ensure we are following the expectations from the state. The pacing guide is an example intended to model how instruction of the AKS and IOAs in each unit may be facilitated. But teachers should design pacing to be responsive to the learning needs of their students. Let's take a look at the vertical progression. Prior to fourth grade, you can see that third grade students are really going to be working with fractions, unit fractions, comparing unit fractions, really getting that understanding of fractions. They do not write anything in decimal notations. The first time students will write numbers as decimals is in fourth grade. After fourth grade, they will be explaining that a multi-digit number that a digit in one place represents 10 times as much as it represents in the place to its right, and 1/10 of what it represents in its place to its left. That's understanding of the 10 to 1. They're going to explain patterns in the placement of digits when multiplied or divided by a power of 10. They're going to read and write decimal numbers to the thousandths place. In fourth grade, we only go to the hundredths place. They're going to represent, compare, and order decimals to the thousandth place. They're also going to be using the symbols to record the results. They will determine and explain comparisons using a variety of tools, just like fourth grade, concrete materials, drawings, number lines, and other visual representations and strategies. In fifth grade, they will also start to round decimal numbers to the hundredth place, and they will solve problems involving addition and subtraction of decimal numbers to the hundredth place using a variety of strategies. The suggested length for Unit 4B is 2 weeks. Unit 4B focuses on AKS 4MA C5. Solve real-life problems involving addition, equivalence, comparison of fractions with denominators of 10 and 100, and comparison of decimal numbers as tenths and hundredths using part-whole strategies and visual models. The suggested instructional sequence is located on the left side of the pacing guide. The left column provides the learning progressions for the AKS and IOAs, showing whether it's a concrete, representational, or abstract. The bulleted list states learning objectives within the IOAs, as well as any suggested manipulatives. The resources for each day are located on the right side of the pacing guide. Resources include traditional lesson plans, task-based lessons, formative assessments, small group instructional moves, student tasks, and any additional resources that are aligned to the learning targets for that day. Also embedded in the pacing guide is suggested resources to use from our textbook adoption, Georgia Reveal. Georgia Reveal is an adopted resource. However, it is not your main and only resource. You will find Georgia Reveal adapted lessons aligned to the intended learning objectives, as well as other resources on the pacing guide. These are just a few of the Georgia Reveal resources available. Please go to your employee portal to access all of the Georgia Reveal resources available to meet the learning needs of your students. Let's look at an instructional day to point out some of the features of our pacing guide. So for this first day on pacing, we can see that the IOA is 5A. It is a concrete representational day. We're going to be representing wholes, tenths, and hundredths with base 10 blocks or decimal grids. That's why it's concrete/representational, connecting those two. We're going to understand 10 hundredths is the same as 1/10. 1/10 is the same as 10 hundredths, and 10 tenths is 1 whole. We're going to demonstrate and explain the concept of equivalent fractions with denominators of 10 and 100 using concrete materials and visual models. You can see the suggested manipulatives there are base 10 blocks, and we also have a link to a decimal place value chart for you to support you. You can see that the lesson on the first day is an adapted Georgia Reveal lesson. It gives you the lesson number and the title of the lesson. There's a check for understanding formative. You have your small groups for 5A and 5B, as well as a suggested task that's also from Georgia Reveal. You can see that this is from the On Your Own in Georgia Reveal, and it gives you the page numbers to support you as well. Additionally, there's a Georgia DOE task under additional resources. Anytime you see a Georgia DOE task linked to your pacing guide, it's going to pull up a large document that has multiple tasks and resources for you, but the link itself is going to open to the page number that is referenced on pacing guide. For the next 2 days, students continue to demonstrate and explain the concept of equivalent fractions with denominators of 10 and 100 to add to fractions with denominators of 10 and 100. So we're starting with just that equivalency, and then we're going to add in where they're going to be adding fractions. You can see that the bullet has been added there, add two fractions with denominators of 10 or 100. Unit 4B then goes into days where Unit 5A and 5B are clustered. You can see on this day here. There are 3 suggested days on the pacing guide for these clustered IOAs. Students will start with 2 days of concrete representational instruction using base 10 blocks and visual models, such as decimal grids, to represent the relationship between fractions and decimal numbers. Then there is 1 day of representational instruction, where an open number line is the suggested tool to represent the relationship between fractions and decimal numbers. Let me scroll down to that one. All right, so you can see here, this is that representational day I just spoke to about. And again, you can see the bullets are showing you that it's suggested to locate decimals on a number line here with the bullets. And then the lesson is locate numbers on a number line. During each of these 3 days, students will be expected to represent, read, and write fractions with denominators of 10 or 100 using decimal notation, as well as represent, read, and write decimal numbers to the 100th place as fractions. So now let's scroll on down to the next IOA, which is 5C. The suggested pacing for IOA 5C is 3 days. We will begin 5C with 1 day of concrete instruction using base 10 blocks to compare decimal numbers to the 100th place. So right here, there's that concrete day. And you can see that the lesson here matches the bullets. There's base 10 blocks here, and we're comparing 2 decimals with base 10 blocks here. After that, there are 2 more days of instruction where we suggest decimal grids, number lines, and place value charts to compare decimals to the 100th place. And students at the abstract level should be able to compare decimals by reasoning about their size. During each day, students will record the results of the comparison with the symbols greater than, equal than, or less than, and justify the conclusion. At the end of the unit, let me scroll on down to the end of this unit. This is a short 2-week unit. There is a suggested unit summative assessment. In Chapter 3, this portion of the video will sample specific instructional strategies that will be utilized in this unit. Please refer to the Analyzing the Standards, sometimes referred to as the ATS, for guidance on additional instructional strategies for each IOA. In mathematics, the emphasis is on reasoning and thinking about the quantities within mathematical context. Specific strategies for teaching and learning are not mandated by the Georgia Department of Education or assessed on state or federally mandated tests. Students may solve problems in different ways and have the flexibility to choose a mathematical strategy that allows them to make sense of and strategically solve problems using efficient methods that they are most comfortable with and that make sense to them. It is critical that teachers and parents remain partners to help each child grow to become a mathematically literate citizen. These standards preserve and affirm local control and flexibility.
For IOA 5A, I'm going to model how to solve a problem both concretely using base 10 blocks and representationally using decimal grids. It is important to use base 10 blocks to help students visualize tenths and hundreds as parts of a whole. Likewise, it is important to allow students to shade decimal grids to support conceptual understanding of decimal place value and the relationship between tenths and hundredths. Let's take a look at a problem for IOA 5A. Ashley ran 5/10 of a kilometer on Monday and 35 hundredths of a kilometer on Tuesday. How far did Ashley run altogether? After reading the problem, I know that I will need to add the amount Ashley ran on Monday with the amount Ashley ran on Tuesday. So, using base 10 blocks, I'm going to need to create the amount of kilometers Ashley ran on Monday and Tuesday. To model this, I can use a flat to represent 1 whole kilometer. I can use rods to represent 1/10 of a kilometer, or I could use units to represent 1/100th of a kilometer. In the problem, it states that Ashley ran 5/10 of a kilometer on Monday. So I will need 5/10 to represent the amount she ran on Monday. So for Monday, she ran 1/10, 2/10, 3/10, 4/10, and 5/10. That is the amount that Ashley ran on Monday. On Tuesday, Ashley ran 35 hundredths of a kilometer. So for Tuesday, I can represent that with 35 hundredths. So I have 10 hundredths. I have 20 hundredths. And I have 30 hundredths. And then there's my 35, 31, 32, 33, 34, 35 hundredths. Now, I need to go ahead and solve. So I need to add my 5/10 and my 35 hundredths. So I have 5/10 and I have 35 hundredths. However, when we add fractions, we must have like denominators. So I need to find the equivalency for 5/10 and see how many hundredths that would be. So I see that 1/10 is equal to 10 hundredths. So I have 20 hundredths now. Trade this one for 10 hundredths. I have 30 hundredths. I have 40 hundredths and 50 hundredths. So I see that 5/10 is also equal to 50 hundredths. So now that I know this information, I am able to solve my equation. I am able to solve 50 hundredths plus 35 hundredths, because now I have a like denominator for each fractional value. So when I add these together, I see that I will have 10 hundredths, 20 hundredths, 30 hundredths, 40 hundredths, 50 hundredths, 60 hundredths, 70 hundredths, 80 hundredths, 81 hundredths, 82 hundredths, 83 hundredths, 84 hundredths, 85 hundredths. So going back to our problem, it says, how far did Ashley run altogether? Altogether, Ashley ran 85 hundredths kilometers. And that's our final answer. So to model with decimal grids, I'm going to shade in the amount that Ashley ran on Monday, which we know on Monday, she ran 5/10. So I'm going to shade in 5/10. There's 5/10 shaded in for Monday. This is 5/10. And on Tuesday, Ashley ran 35 hundredths of a kilometer. So I'm going to go ahead and shade in 35 hundredths on my decimal grid that's decomposed into hundredths. There's 35 hundredths shaded in. Okay, just double checking to make sure. And this is 35 hundredths. Now I need to add these amounts to figure out how much they ran all together. However, when I'm adding fractions, I want to make sure that I'm adding fractions with like denominators. So I can say that 5/10 is also equivalent to 50 hundredths. So I'm going to shade that in with my decimal grid. I'm going to shade in 50 hundredths. So now I can add fractions with like denominators. And I can add 50 hundredths plus 35 100ths. And I can do that on my decimal grid. So I'm going to shade in the 50 hundredths to represent the amount that Ashley ran on Monday. Next, I'm going to shade in the 35 hundredths to represent the amount that Ashley ran on Tuesday. 31, 32, 33, 34, 35 hundredths. Now I can see that I have shaded in 85 hundredths. So Ashley ran 85 hundredths total kilometers on Monday and Tuesday combined. For IOA 5B, I am going to model how to solve a problem both concretely using base 10 blocks and representationally using decimal grids. Let's take a look at a problem for IOA 5B. Gerald rolled his toy cars down a ramp. He measured the distance each car rolled from the end of the ramp. Car A, 92 hundredths of a meter. Car B, 4/10 of a meter. Car C,
1 2500 meters. So, the problem is asking us to write each distance as a decimal and as a fraction. Let's start by creating this concretely using our base 10 blocks. So, taking a look at our base 10 blocks, I see that 92 hundredths of a meter needs to be made for car A. I know that 1 whole meter would be our flat. But we have to make 92 hundredths of a meter. I know that 1 whole meter is made up of 100 100ths, or 10 tenths. I can represent 92 hundredths as 9 tenths and 2 hundredths. That would be 92 hundredths. I can write this as a fraction by saying 92 hundredths. I can write this as a decimal as 92 hundredths. And that is for car A. For car B, it went 4 tenths of a meter. So using my base 10 blocks, I can use 4 tenths. As a fraction, this is written as 4 tenths. And as a decimal, it is written as 4 tenths. Lastly, for car C, it traveled 1 25 hundredths meters. So to represent that with base 10 blocks, I need 1 whole plus 25 hundredths. I can represent 25 hundredths with 2 tenths and 5 hundredths. Now, to write this as a fraction for car C, it would be 1 25 hundredths as a decimal. I would write that as 1 25 hundredths. Now, to solve this representationally, I can use both a place value chart and decimal grids to help me. I'm going to start by placing these values on a decimal place value chart. For car A, I have 92 hundredths of a meter. So I'm going to write this as 92 hundredths. For car B, I have 4 tenths. So I'm going to write this as 4 tenths. And for car C, I have 1 25 hundredths. So I'm going to write this as 1 25 hundredths. Now I need to represent this using my decimal grids. For car A, I need to have 92 hundredths. So I'm going to use my decimal grid that is decomposed into hundredths. I'm going to shade in 92 of the hundredths. I can represent this as a decimal by saying 92 hundredths and as a fraction by writing it as 92 hundredths. For car B, we have 4 tenths. So I can use my decimal grids decomposed into tenths. I can shade in 4 of the tenths. And I can write this as a decimal as 4 tenths, or as a fraction as 4 tenths. Now for car C, it traveled 1 and 25 hundredths. So for 1 and 25 hundredths, that means we are already beyond 1 whole. So I will need 2 decimal grids to model this. So I'm going to put down 2 decimal grids that are decomposed into hundredths. I'm going to need to shade in 1 whole decimal grid. So I'm going to shade in 100 100ths or 1 whole decimal grid. And I'm going to need to shade in 25 hundredths more in the second decimal grid. So now I can write this as a decimal and as a fraction. So to write this as a decimal, I can write this as 1 and 25 hundredths, or 1 whole and 25 hundredths more. And as a fraction, I can write this as 1 and 25 hundredths using a mixed number. Now, one more thing I could do with these numbers is order them from least to greatest or greatest to least. I'm going to order these numbers from least to greatest. So, looking at these values, I'm going to first compare 92 hundredths and 4 tenths. I can compare that by looking at my decimal grids. I can see that 92 hundredths has more shaded in than 4 tenths. Now, 4 tenths can be represented as 41 hundredths, so we can compare fractions with like denominators. So, I can shade in my decimal grid decomposed into hundredths to better compare. And so when I compare 92 hundredths to 40 hundredths, I can easily see that 40 hundredths is less than 92 hundredths. So in ordering these from least to greatest, our lowest amount would be 4 tenths, or 40 hundredths. Now I can compare 92 hundredths and 1 and 25 hundredths. Well, now with these two values, I know that 92 hundredths is less than 1 and 25 hundredths, because for 92 hundredths, I shaded in less than 1 whole. Whereas for 1 and 25 hundredths, I shaded in 1 whole and 25 hundredths more. So I would have my order from least to greatest as 4 tenths, 92 hundredths, and 1 and 25 hundredths. I can also write these as fractions by writing 4 tenths as 4 tenths, 92 hundredths as 92 hundredths, and 1 and 25 hundredths as 1 and 25 hundredths. For IOA 5C, I'm going to model how to solve a problem concretely using base 10 blocks and a meter stick, representationally using decimal grids, and abstractly using a place value chart. Let's take a look at a problem for IOA 5C. Katie is doing a science experiment in which she rolls her toy car down a ramp. She measures the distance the car travels past the end of the ramp. The first time down the ramp, the car traveled 7/10 meters. The second time down the ramp, the car traveled 63 hundredths meters. Which time down the ramp did her car travel the longest distance? Write a comparison statement using greater than, less than, or equals to show the car that traveled the furthest. First, I'm going to model this using a meter stick and base 10 blocks. I'm going to model first creating the car that went 7/10 meters. Notice that my meter stick represents 1 whole meter. We know the car traveled less than 1 whole meter because 7/10 is less than 1 whole meter. So I'm going to go ahead and model this. I have 1/10 of a meter, 2/10 of a meter, 3/10 of a meter, 4/10 of a meter, 5/10 of a meter, 6/10 of a meter, and 7/10 of a meter. So the first car rolled 7/10 of a meter. The second car rolled 63 hundredths meters. 63 hundredths of a meter can also be represented using 6/10 and 3 hundredths. So we have 10 hundredths of a meter, 20 hundredths of a meter, 30 hundredths of a meter, 40 hundredths of a meter, 50 hundredths of a meter, 60 hundredths of a meter, 61 hundredths of a meter, 62 hundredths of a meter, and 63 hundredths of a meter. So we can look at our model and see that 63 hundredths is less than 7 tenths. So when I write my comparison statement, I can say that 7 tenths is greater than 63 hundredths of a meter. Now I'm going to model using decimal grids. I will start by shading in 7 tenths on the decimal grid to represent 7 tenths. As a decimal, I can write this as 7 tenths. Now I can model 63 hundredths using a decimal grid. So I'm going to shade in 63 hundredths. So to write this as a decimal, I can write this as 63 hundredths. So to truly compare, though, because we want to compare like denominators, I can shade in my equivalent for tenths to hundredths to compare fractions with the same denominator. So I will shade in 70 hundredths, which is also equivalent to 7 tenths. So now, looking at this, I can compare my two decimal grids. I can easily see that 70 hundredths is greater than 63 hundredths. So now I can write my comparison statement that 7 tenths is greater than 63 hundredths. Lastly, I'm going to model using a decimal place value chart to compare. So on my decimal place value chart, I'm going to write down the distances the cars traveled down the ramp. The first car traveled 7 tenths, and the second traveled 63 hundredths. So I can write these on my decimal place value chart as 7 tenths and 63 hundredths. Now that I have these values written on the decimal place value chart, I can take a look at these to compare. I see that I have 7 tenths here and 6 tenths in the value of 63 hundredths. So when I compare these values, I can already see that 7 tenths is greater than 63 hundredths. When we compare decimal values, we're going to look at the tenths place first to compare values. Look at the tenths place. I can already see that 7 tenths is greater than 6 tenths. That means that 7 tenths is greater than 63 hundredths. And I can write my comparison statement by saying that 7 tenths is greater than 63 hundredths. So, going back to the problem, which time down the ramp did the car travel the longest? Well, the longest distance is when the car went 7 tenths of a meter. So the final answer to this problem is 7 tenths meters.